So this is on page 226 in the textbook. It's a 25-gram chestnut with a hole drilled through its center. I don't know where they come up with these ideas. It's hanging from a long, massless shoelace. What does that mean? A massless shoelace. It's a shoelace that has no mass. In other words, we're ignoring the mass of the shoelace, is what they're saying. A child spins the chestnut in a vertical circle at a speed of 4 meters per second. If the shoelace is 80 centimeters long, determine the tension of the shoelace at the top and bottom of the circle. Also find the critical velocity. How about we find the critical velocity first? That's the easy one, right? Let's do that part first. What was that formula from yesterday? V min is square root R times G, I believe, right? And our 80 centimeter long massless shoelace has to be in meters, so that's going to be 0.8. And then, do I need the minus? No, I do not want the minus. .8 meters per second. Is that what you got? Okay, so the kid is whipping it around faster than that, so it's actually going to make the entire circle, right? Okay, let's draw a little picture here. So we're supposed to find the tension of the shoelace at the top and the bottom. And remember, at the bottom here, the tension is greater, and at the top, the tension is less, right? That's what that sort of hieroglyphics means. Less than at the top, greater than at the bottom, right? Okay. So what is the required centripetal force? Well, that's going to be mv squared over r. The mass is, you got to convert that to, does yours say 25-gram chestnut? That's what? 25 grams? Has someone got their textbook handy? Can you just look up there on page 226? Alyssa, can you look it up? My notes say it's 250-gram chestnut. That's even bigger. In fact, 10 times bigger, Martin. Just wait till I'm done. Yeah. I don't want you to say anything. What does it say, Alyssa? In the textbook, they say 25 grams, but then in the answer, they use 0.25 kilograms. So in other words, it's 250. And the only reason we're doing this is so that it matches what you have in the book here. I guess it's not on page 226. All right, so the mass, 0.25. The velocity, 2.8. And my pen needs to be reoriented. Radius, 0.8. All right, so you get a centripetal force of 2.45 newtons. Okay, so now at the top. What the heck? Also got to know the weight force. 0.25 times. Now this time, should I include that negative 9.8 in there? And the answer to that is yes. Okay, so again, at the top here, you've got centripetal force down, but that centripetal force is made up of the weight force and the Ft, the tension, right? The weight force and the tension are both contributing to that centripetal force. So the Fc is equal to the weight force plus the tension. And that centripetal force at the top has to be down, so it is -5. It's a real test here of your ability to figure out positives and negatives and directions and making sure it's in the right order. The weight force is down at -2.45 plus the Ft, or the tension, which is what we're solving for. This is from yesterday, Josh. Nothing new today. Yeah, the second one from yesterday. And so when I take that -2.45 to the other side, I get -5 plus 2.45 is equal to Ft. And you get -2.55 newtons, which is less than the centripetal force, which makes sense, right? Right? The tension in the string is going to be less than what's needed because gravity assists it in bringing it down. How do we do it at the top? Or sorry, at the bottom? Same idea. The centripetal force has to be up, but that centripetal force is made up of tension as well as weight force, but they're in opposite directions. Same setup at the start. And that centripetal force is our 5, right? This time it's up, so it's +5. The weight force still down, -2.45 plus the Ft. And when you take that -2.45 to the other side, you get 5 plus 2.45 equal to Ft. And you get 7.45 newtons, which is more, which is what we know at the bottom of the loop, the tension is greater, right? Okay, so just very quickly for Bailey and Shaden and Cassandra, they were yesterday, right? When it's in a vertical circle like this, at the bottom, the tension is greater. How come? Because gravity's pulling down, but you have to pull up. At the top, at the top, the tension's not as much because gravity is also assisting in pulling down, right? So then you don't need as much tension to pull that down. So as it goes around, okay, where's the speed of the greatest, Bailey? In fact, at the very bottom it's at its greatest, right? It accelerates on the way down, but at the bottom it's at its fastest, and then it slows down again at the top, right? So less tension, slow, more tension, fast. Okay? You can watch the video if you want sort of the full version of that, but that's sort of the short version. Okay, so you have that sheet from yesterday. There is also some textbook questions if you want to try. They're a little bit more, generally it can be a little more challenging. They can be a little bit more fun though. They're kind of a little weird. So that's 226:15 to 25. And I have the first pretest as well. Should I hand it out today?
Yeah.
Okay. I will do that, and I will give you the rest of the period.